Hello and welcome for those of you that are taking class with me in data analytics and business modeling. And for those of you that are just popping in to learn a little bit about using Python and sklearn and logistic regression inside Jupyter Notebooks and Google Collaboratory, welcome. Welcome to everybody. So here's what we've got. In order to sort of pick up where we've left off, we're working on a data set that has gender information, height, and weight for, we'll say, young adults / children. And a few things you want to pay attention to when you look at the data. The height that you see is in centimeters. This is very much so a public data source that we're using. So it's height in centimeters, and we'll say it's weight in pounds, although it could be kilograms. I'm pretty sure it's weight in pounds. Either way, it will affect our outcome, but the way we write the code won't really make that big of a difference. A few things that I want to point out to you as you look at the head and the tail of the data that's on the screen right now. This is a data set we manipulated in previous videos, so we've cleaned this up a little bit. We've dummy coded gender. So in this particular case, you've got one hot encoded a gender column. So 0 in the first column that says female would indicate that it is not a female, and a 1 would indicate that it is a female. So we don't have both a male and female column. We've dropped 1 to try to avoid the dummy trap, although we don't really need to drop 1 here. It's just a good practice to do so. So we've got basically gender 0 meaning that it is a male and 1 meaning that it is a female. And we've got height and weight that are happening here. Now in the previous video, and I can really quickly, I can jump back up in the code and show you some of the stuff that we did really quickly here. We loaded the data from our Google Drive, which you would need to do that if you were working in Google Colab. You would mount a Google Drive. You would take your file, drop it in Google Drive, and you would mount that Google Drive file. We then just explored our data a little bit. Of course, we imported some libraries up here, which I'll do those again kind of down at the bottom. Note that Logistic Regression Model is already imported, but I'll do it again just to show you how it works. So we looked at the head of the data. We dropped null values because there were 2 records that were missing values. We dropped a couple columns here. So we dropped the index column. We dummy coded the gender column. You see we did that down here. We took the original data frame and the dummy coded data. We concatenated those together and then dropped gender. And then we reorganized them so that, there you go. We have gender here, then we have height, then we have weight. And that is where we are picking up. So the first time you've seen this, or we have not talked about this before, but there's a practice that you see quite a bit when you're working with machine learning and with deep learning, and it's called the train test split. And it's a good practice to take your entire data set and take a little bit of data off of that data set, set it aside, and save it to test the accuracy of your data model. So you'll have a portion of your data that is used for training and a portion of your data that you would use to test your model just to see how accurate it is. Okay. So now it's pretty easy to do that when you're using scikit-learn, when you're using sklearn, it's pretty easy to do. There is a set of skills or libraries that are built in that will allow you to do that in sklearn. So what we're going to need to do is we're going to want to break this data into 80% training data and 20% testing data. So 80% of my 498 rows I will use to train my model. And we will do logistic regression this time instead of linear regression. And the other 20% we will save to test our model. So now before we do that, let's talk about logistic regression for just a second. And what that really does for us versus linear regression. So with linear regression, you're going to get an output, a numerical output that's a continuous value, right? So that's the y equals mx plus b formula that you guys are so familiar with. But when you talk about logistic regression, specifically, this is binary logistic regression where you're just going to get either a 0 or a 1, and that's it. It's not a multi-classification regression. What you get is, first of all, it uses something called a sigmoid function. So it's not a linear function. It's a different equation. You don't really have to worry about that so much in this class. Just know that your output is going to be a 0 or a 1, and that is it. It's not going to give you a continuous value. Now, this is interesting. So here's what that does with logistic regression. It's going to take a predictor value, whatever predictor value we want. We could use weight, we could use height, whatever you want. And then based on that, it's going to give you a categorical predictor or a categorical output. So it'll tell you either 0, meaning male, or 1, meaning female. So the output of a logistic regression, if it's a binary logistic regression, is simply 0 or 1. So it'll say, hey, your data, we predict it will fall into this category. So if I give it a weight, it will predict a specific output, either male or female. And that's what we want to look at now. So now we talked about that 80-20 split that we're going to do, which is a pretty good practice. And it, it depends on how much data you have. If you don't have a ton of data, you could do a 90-10 split, for example, if you don't want to use that much data for testing. But either way, it's something that you would want as a good practice. And I'll give you a little tip for you guys that are out there preparing for your big day next week. The 80-20 split was something that your predecessors in previous classes kind of just omitted, and they got dinged for it a little bit. So if you're going to do something machine learning wise, either in R or Python, make sure you pay attention to that training versus testing data set. So we're going to take those 498 rows of data. We're going to slice and dice it up. A little bit goes to, or a lot of it goes to training, and a little bit goes to testing our model. So how do we do that? Well, we're going to start off by bringing in the sklearn library. But from sklearn, instead of bringing in just the linear model or the logistic regression model, we're going to do model selection, and we're going to go import. And this time we want to do, I love that autocomplete now, train, test, split. Okay, just like that. Okay, so now this is a skill. This is part of this sklearn library that will allow us to automatically split this up. And it's actually pretty easy to do. So if I start typing train, test, split, it automatically starts filling it in for me. Okay. Now, if you look up at the top, you'll note that the data frame that we finished working on, that we finished pre-processing in the pre-processing video, is called final. So right here, this is the final data frame that we've created. Note it's called final. So what I'm going to do is I'm going to start off by typing train test split, train underscore test underscore split. And then from there, I'm going to take final. Okay. And I'm going to take as my X, my predictor value, we will take weight. Okay. And then I'm going to jump over. Notice I've got those two brackets because it wants that two-dimensional array. And I'm going to take final, and we are going to take the female column. If I could spell, the female column from that. Now, we're not quite done. Okay, so all we've said is we're going to split up the data with the X value being weight and the Y value being female. Okay, so test and train, right? And then from there, well, not test and train, we're saying X and Y, okay? From there, we are going to say that the training size, which is what we just talked about, is we will do 0.8, okay? So it's going to break our data into 0.8. Now, note that it's popping up some data here to try to help me. And it's telling me all these different things about parameters and what it returns. And if I scroll down, and shout out, I've seen this in other videos, and I've actually never used this trick before up until recently, where I copy this and paste it in. I've just manually typed them in before when working with like neural networks and things like that. But you could actually just jump right down here, and it tells you, hey, you are going to output xtrain, xtest, ytrain, and ytest from this test train split. Now that's probably confusing if you've never seen this before. So for now, I'm just going to copy it. Funny enough, I'm just going to, let's see if I can cheat a little bit. And what we need is in front of this train test split, we actually have to type, there we go, equals train test split. Okay, so let's talk about what that is exactly. Okay, what you get. So the train test split method that you have that's happening here, that's coming from sklearn, is it's going to output a set of different of information. It's going to give you an xtrain set of information. It's going to give you a ytrain set of information, right? So X and Y is part of your regression. So it'll say this is the X value for training data. This is the Y value for training data. This is the X test for training data. And this is the Y test for training data, which is probably still pretty confusing. So when in doubt, why don't we just look at it? So if I type xtrain, And I always want to capitalize the T, but we're not going to do that. There we go. Here's what it's going to show me. So notice that it brought 398 rows of data and it gave me weight, right? Because remember, the weight is the predictor. And if I jump down to the bottom and I type Y train, all of a sudden it's telling me a bunch of zeros and ones, isn't it? 0, 0, 1, 1, 0, so on and so forth, right? And it's that same 398. So what it's telling you is these are the predictors and these are the outcomes of the training data. Now, if I did the same thing with test, x underscore test, it's going to give me all of my testing data. So you see that it held out 100 rows. Okay, so 100 rows of data has been saved for you to use as a test, to test your model and see how accurate it is. And that's the X test. And we know the answer, right? We know what this should be if we ran the X test values through our model. So because we already know the answers, right? So the X test and the Y test data came from our original data set. So we know what the answer should be. Like if we know the X for this set of values, we know the Y because it was in our original data set, right? Now I can see it, but I also know the answer. So what we can do with this is we can basically run these X test values through our model that we're about to create, and we can check to see if it predicts correctly, right? Based on what we know. Now, there are some things that could cause this to be off, but I don't want to talk about that yet. We'll get to that in a point. So for now, just know if you want to see it, first of all, we know that this test train split trick just worked. It split our data into 80% testing data, or excuse me, training data and 20% testing data. All right, so at this point, we can proceed with basically just using our regression. Now we're going to run our regression. This time we're going to do something different. We're going to do a logistic regression instead of doing a linear regression. So what we want to do is predict if it's a female or male. We don't necessarily want to get a continuous value output. So now I'm going to go back, and I probably did it at the beginning of this. Let's look. I surely did. So up at the top, when I pulled in my libraries to start, I pulled in the linear model, but instead of, the SK linear model, but instead of the linear regression, I pulled in the logistic regression set of information, right, of tools. So instead of the linear regression here, I've got logistic regression. So that's already pulled in. If you didn't do that, you're going to want to type that same line of code, right? So I'm going to go in and I'll say from sklearn.linear model, import logistic regression instead of linear regression. Now the 80-20 split that we just did will work with anything. It doesn't have to be logistic regression. So in this particular case, if you wanted to do linear regression, or if you're working on a linear regression in your project, simply take this logistic regression that you have here, and we would just replace that with linear, and it would give you the linear regression model object that you could call and work with it as you see fit. Okay, so let's jump back down. All right. So quick reminder of where we're at. We've got a clean set of pre-processed data where we have done all the slicing and dicing of the data to make it exactly the way we want. We have gone through and we've split our data up into 80% training and 20% testing. We've got our X's and our Y's defined. And at this point, we are ready to actually start working on that regression. And you know, it's actually pretty easy to do the regression stuff. So here's what we're going to do. So first thing we're going to do is we're going to create the regression model. And we're going to do that by doing logistic regression, like so. And there's one thing that'll be slightly different from what we did before. If you're following along with other videos, we didn't do the 80-20 split, which basically made X train and Y train variables. In the previous videos, we actually just referenced the specific data frame columns, which required two-dimensional arrays. And it would have looked something like, DF. Well, you know what? Let's not even mess around with what it would look like. Let's just say that this is going to be a lot easier when we fit the data, because X train and Y train, we can just plug right into the parentheses of the regression model fit. So if I jump down here and I do my regression model dot fit, and then I'm going to do my X train and I'm going to do my Y train like so. That's it. Just like that. Okay. So now here's the part that's really cool. So remember, we've got that testing data that we can now fiddle around with. Well, I can go to my regression model and I can do a couple different things, right? So the first thing I can do with my regression model is I can just straight up use it. So if I go regression model predict, and I type in, 80 pounds, it's going to tell me 0, which indicates that that is not a female. And if I were to jump in and turn and type in 190 pounds, it's going to tell me 1, in which it thinks that that is a female. How interesting. Okay. So first of all, that's just me using the model. Okay. But we can use it a little bit more. So here's where it gets more interesting. All right. So I can jump in and I can use this model again. So I can go regression model dot predict. And this time, instead of typing in just a number, right, and I put that in as a 2-dimensional array and it's telling all of that in there, I can literally just type x_test. And when I do that, it's giving me predictions for everything. So all of my X test data, right? So if I look at X test again, there's all my X test data, right? So it's saying 74 pounds, it thinks that that is a male. And 115 pounds, it thinks that that is a female. 71 pounds, it thinks it's males. 110 pounds, it thinks it's male. Well, I take that back. Scratch that for a second here. When I look at this, nope, this is correct. So it's telling me what these are, and these are the predictions that go along with it. So we're okay. Okay, with my X test. Let's run that one more time. Yes. Okay. Very good. Okay. So that's what it's thinking. And I can do the same thing. So I can do, what else can we do? Let's think. We can look at our, we can look at the effectiveness of our score, basically how correct is our score. We also have the ability to look at the probabilities of it being correct, like how close was it between male and female. So a couple of things we can do. So we're looking at the X test, right? And we're seeing the values that are coming from running the X test. From there, let's say we do something like regression model dot predict, and this time, or excuse me, not predict, we'll do score. So now when we do score, what we're going to do is we're going to plug in our X test and our Y test. So X test and our Y test values. And when I do this, it's telling me, uh-oh, as my niece would say, uh-oh, we're actually only 43% accurate. So our model's not very good. Okay. Uh-oh, model's not very good, 43%. So there's a couple different things that could be happening here. And there are a couple different things you could do to improve your model, which I can give you some of them off the top of my head. That's not really why we were doing this video, but it was just something that I would chat about. So a couple things that we could do to improve, because as of right now, this is not the best model at 43% accuracy, not the greatest. But there are a couple different things we could do to improve. So number one, we remember when you do any kind of regression, there's all these assumptions. It could be that we have some very, very, very extreme outliers. So those outliers could be causing some issues with our data. So that might be something we would want to look at. So for example, we could have a female that is way below the average weight, like way, way, way below, or a male that's way, way, way below the average weight. So we could have something with an outlier that could be happening there. We could have values in our data that for some reason are off, although we went through the pre-processing of that earlier. And those are some of the big ones, just kind of flowing off the top of my head. A couple other things you could do. You could add more data. Like if we have more observations, we could add that to our data. The more data we have, the more accurate our model can be. Although this is a pretty decent amount of data that's happening in here. It's 500 lines of data. Okay. So just a couple different things you could check on. One last cool thing that you can do if you're interested, if you wanted to see the specific probabilities, like how close was it to being one or the other, I can show you that. And really what it does, and let's take a look at that for a second. So I'm going to do regression model, and we'll do dot predict. And you see how it's starting to fill things in for me. We'll go down to probability, but it just says proba A, like so. And from there, we'll type in our X test, which is our outcome, or excuse me, our predictor value. And when I do that, it's going to give me a bunch of probabilities, right? So it's saying the probability of the first X value that came in of being 0 or 1 is this. Okay, the probability of the next one is this. And so on and so forth. Okay, and I have to scroll all the way up to the top. So you should now, so these predictions, these probabilities that you're seeing should actually very, very closely coincide with what you see up here. So 0, 1, 0, 0, 0, whichever one of these is closer to 1 is going to give you either a 0 if it's in this column or a 1 if it's in that column. So it's giving you your probabilities, which is actually pretty handy as well. So that's something you guys want to check about. And notice that it's super duper close on most of these things. There's not a major margin for error here. So that's also something that'd be interesting to work on. But for now, that's the end of it. Quickly summarize some of the things we did. We looked at doing our test train split with sklearn, which is really a big deal. That's something you'd want to do whenever possible. And we did a logistic regression, albeit the data wasn't all that accurate. We were able to do it. We were able to execute it and see how that all works out. So with that, friends, I will bid you adieu. And I will talk to you guys soon. And I'm open to requests if there's something you're interested in, or if there's something we could talk about a little bit more. Like all those young kids out there say, please like and subscribe to my YouTube channel. It makes me feel so good that the 5 of you out there that watch these videos are actually paying attention and getting good information from it. So I will talk to you guys soon, and I will see you guys in class.